If we're given a graph of y equals f of x, maybe like the one here in example 1, and also some positive number c, what does the graph of f of x plus c look like? And also, what does the graph of f of x minus c look like? Here, f of x represents a y value, so this plus c means you're going to add that number to the y value. This minus c means you're going to subtract that number from the y value. Let's examine this idea in example 1, where y equals f of x just represents this sketch here. What does the graph of y equals f of x plus 3 look like? So I'll put this over here in blue. But anytime that you change a y value, it's very straightforward. The plus 3 means it's going to move the graph up 3 places. So I'm just going to put up 3. So if you look at, let's say, these 3 points on your equation, the y value for this point, for example, is at 3. If we add 3 to it, it goes up 1, 2, 3 places here. So I'll plot a point that's 3 units above where we started. I'm going to do the same thing for this point here. If I go up 3 places, I'm here. And this last one, it has a y value of 5. If I go up 3 places, I'm now at 8. In fact, every point on the graph does this, meaning this is your new graph. This is the graph of f of x plus 3. So very straightforward. Here this 3 means you're adding 3 to the y values. Therefore, the whole thing just goes up 3 places. Now, if you compare that to f of x minus 2, probably no surprise. Maybe I can do this one in green. This minus 2 is happening outside of the function, meaning it's changing the y values. And this is going to go down 2 places. So again, you start at your original graph, look at each y value, and move it down 2 places. This one was at a y value of 3. It's now at a y value of 1. This is at a y value of 0. It ends up to a y value of negative 2. And this last one, okay, this goes down 2 places. It was at 5. It ends at 3. This is the entire graph of f of x minus 2. So it's pretty straightforward if we talk about something called a horizontal or a vertical shift in this case. A vertical shift means the graph is either going up or down, and the number outside, if you're adding it or subtracting it, tells you how far you actually go. And that's all we're looking for in this example. But here's where things get confusing. So again, let's use the same function y equals f of x, which is right here. What happens if you this time add and subtract some number, not outside the function, but inside the function? What this means is you're now changing the x value. Here I'm adding some number to the x value. Here I'm subtracting a number from the x value. And as we've seen up to this point, anytime that you change an x value, the opposite effect happens on the graph. Like let's look at y equals f of x plus 3. I would think that this is changing the x values, which is correct because it's adding 3 to the x. So if you look at this point here, its x value is 5. You would think it would go 3 places to the right, but actually it's going to do the opposite, where we're going to go 3 places to the left. So that's going to happen for every single point on this graph. So if I look at y is equal to f of x plus 3, you would think it goes right 3 places, but in fact it goes left 3. So let's sketch this entire graph. This point has an x value of negative 3. If we go 3 places to the left, it now is at negative 6. This point has an x value of 0, so it's going to end up at an x value of negative 3. And this point has an x value of 5, and like we said, if we move 3 places to the left, it ends up at 2. Every point does this. and this is a graph of f of x plus 3. So this is very different than the previous example. First of all, in the previous example, the 3 was outside the function, meaning it changed the y value, which is why the graph went up or down. But here, anything happening with inside the function changes the x. So it's got to be some type of left or right movement, like you're going along with the x-axis. You would think it would go right 3, but in fact it goes left 3 places. Now, if we compare this to the second one, which is y is equal to f of x minus 2, again, clearly we're changing the x's because we're working with inside the function. And it might seem like the graph would go left 2 places, but in fact, this is going to go right 2 places. So let's sketch it. I'll start with this point here. The x value goes right 2 places, so it ends up at this spot here. This point goes right 2 places. And this spot goes right 2 places. So the green graph represents f of x minus 2. So this would be a horizontal shift. And the reason for that is if you're changing only the x's, that means you're moving either left or right. If you can keep in mind that the opposite happens when you change your x's as opposed to your y's, that'll help out a lot for the next examples coming. So for this last example, here we have, again, the same function that we've been starting with, which I'm calling y equals f of x. I want to sketch a graph of f of x minus 4 plus 5. So in this example, we have 2 changes happening. We're both changing the x's as well as the y's, because this minus 4 is attached to the x, and this 5 is outside of the function. The order in which I'm going to move the graph around will follow order of operations, in that I'm going to work within the function first, inside the parentheses, and then addition will be second. So I'm going to make this a 2-step process. If I want to graph y equals f of x minus 4 plus 5, the first thing that happens is the x minus 4. And this is changing the x's, and I see a minus 4. This actually goes right 4 places. Now the second thing that happens is this 5. This is outside of the function and it's changing the y values. It's going to do exactly what I'd expect, which is going to go up 5 places. I'll take the 3 points on my graph, run them through these 2 steps, and then sketch the entire graph when I'm done. So let's start here. We're first going to go right 4 places, and then we're going to go up 5 places. And we end up at this location here. This is 1, 8. Let's do that for the remaining 2 points. This spot right here is going to go right 4 and then up 5 to 4, 5. This last point, it's going to go 4 places to the right and then up 5, and we end at this spot here, 9, 10. If every point on the graph does this, the shapes of the 2 graphs should be the same, it's just now in a new location. If I take this whole graph, move it right 4 and up 5, we would have this picture here.